Okay, 3.4, basically it's a lot of story problems. You just have to, whenever you read a story problem, you just have to know what you're talking about. And basically, I got this from this app from physics because they were questioning this one year. A negative 9.8 meters per second squared is gravity of the Earth pulls it down. We'll talk about that later in a few minutes, but it's a negative because of the gravity pulling it down. Okay, we want to talk about when they want you to find the position or the initial. I spelled initial wrong. If they ask you to find the position or the initial value, they're just talking about f of x throughout the rest of the book. These are just important words for the rest of the year that you need to know. The units, if they ask you, it's in meters or feet or whatever they're talking about. When they ask you to find the velocity of something, when they ask you to find the slope of something, when they ask you to find the rate of something, you need to find the derivative. So those three key words in a problem, something should be going off in your head, and you should say, well, they just said velocity, that means I have to find the derivative. They just said rate, that means I have to find the derivative. They just said slope. How do you give the answer? You give your answers in meters per second, or whatever type of units that you're talking about. The next one, they usually say acceleration. They don't usually say anything else. When they talk about acceleration, you need to know, you have to find the double derivative. And how do you label it? Meters per second squared. And a lot of you that had physics before kind of know how to label these. So the last one, I don't know if you have, I'm sure you have this in physics. If they ask you to find the speed, specifically speed, it's the absolute value of the derivative. Absolute value of the derivative. And you still label it just like the derivative meters per second. But just remember speed. Anytime they ask you to find the speed of something, it needs to be positive, correct? You don't go negative 45 miles per hour. You go 45 miles per hour. Not negative, it's always positive. So, part one. This is a sentence, and what you need to do is key on the important things. Find the rate of change of the area of a circle with respect to the radius if the radius is 5 meters. The key word in this problem, anybody know what the key word is in this problem? Rate, right? So you should probably circle it on the AP test and say rate, okay? They're giving you the formula of the area that you would know from geometry, right? Area is equal to pi r squared. But guess what? We're going to find the derivative of a prime. You can write it two different ways. You could put a with a slash, which means a prime, correct? Now, some of you are getting used to looking at different ways to write derivative. Here's the way you would write this one. The derivative of the area with respect to what letter? What's the letter that they use? R. These two right here, a prime and dr means find the derivative. So anytime you have two different letters, this one goes on the top, this one goes on the bottom, and ready to find the derivative? Isn't pi just a number in math, 3.14, right? So if I ask you to find the derivative, don't you just multiply the pi and the 2 together, right? Which is 2 pi. What happens to the power? Doesn't it go down by 1? Aha! This is really cool, you guys. The derivative of area is what? 2 pi r, which is the circumference. Isn't that cool? Bet you guys didn't know that. Pretty cool. Video people, really cool. Okay, well, we got to finish this. So they want to know what's the rate of change of the area of a circle with respect to the radius. If the radius is 5 centimeters, can't you just put 5 in place of r? And you don't have to solve it. You can just leave it as 10 pi. So we see how we got 10 pi? We just put 5 in for r. Multiplied it by 2. 10 pi. I'm trying to figure out. We don't have meters per second. I can't really label it, can I? So just the units. I don't even know. Just leave it 10 pi. Just leave it. Okay, moving on, next page. Um, Displacement of an object. Really, really, really important how to find the displacement, how much it moves. And again, this is physics. How does it move? Not moves, just move. The formula is FB minus FA. So this is the X value, and you're trying to figure out how much displacement did this object move from. And you're moving from 0 to 4, correct? All you do is you put the bigger number in first. 4 squared is 16. 16 plus 2 is 18. Minus, it's just the bigger number minus the smaller number is how much an object would move from 0 to 4. Again, how did we get 18? I put 4 in and got 18, and then I'm going to put 0 in. 0 squared is 0. 0 plus 2 is 2. So how much did this object move? It moved 16, and I don't know what we're talking about again. I don't know if 16 meters or 16 feet. I'll just pretend and put 16 feet. They're going to ask you to find the displacement, how much an object moved. It's the bigger value minus the smaller value. Does that make sense? To find displacement of some object moving. Okay, here comes a really, really long problem. And this is on the next test. It's worth a lot of points. This is on the next test, and it's going to be a lot of points because there's a lot of parts to it. So, where is it? Right here. A particle moves along the line so that its position at any time t has to be greater than 0. They're talking about time needs to be greater than 0. Is this? They're telling you that the position is this, and we just talked about what position is. It's just a regular formula, right? Which is what? T squared minus 5t plus 4. They want you to find the displacement for the first 6 seconds. How much did it move for the first 6 seconds? So you need to put in the biggest number. Basically, you're going from 0 to 6. It doesn't tell you 0, but you should know what's the displacement from 0 to 6. Do we understand that? So all you're going to do is you're going to put 6 in here. And you're going to get 36 minus 30 plus 4. And 36 minus 30 is 6. And 6 plus 4 is 10. And you're going to subtract it from, when you put 0 in, this comes out to be 0, this comes out to be 0, so you have 4. So find the displacement for the first 6 seconds. It moved 6 units is meters in seconds, so it moved 6 meters. 6 meters. So it should be easy to find displacement. How much did it move from one point to the other? Highest number minus the lowest number. Now, if they ask you on the test to find the average velocity it moved for the first 6 seconds, you're just finding the average. How much did it move? You take the A part, which is 6, and you divide it by 6. If your displacement for the first 6 seconds, you're moving 6 meters, aren't you averaging 1 meter per second? Wouldn't that make sense, you guys? Right? Final answer. Just to look back at notes, this 6 is the average. This 6 came from there. That 6 came from there. Now, if they ask you to find the instantaneous velocity, really, really important word, underline it. It's the official word to find the derivative. It's the official word to find the derivative. So if they say, for the rest of the year, if they say find the instantaneous velocity, you're going to find the derivative, and it's really easy. S prime of t is the proper way to write it. And this is really easy to find the derivative of that, right? What's the derivative of t squared? Review, t squared is 2t minus 5, right? So that's the derivative, and all you have to do is put 5 in place of t, and you get what, 5? But they want you to label it. And what's the instantaneous velocity? 5 what? Meters per second. Now they want you to find the acceleration at t equals 5. So acceleration is double derivative. Again, we're not really learning anything new. We're just learning that acceleration is double derivative, and the double derivative, what's the derivative of 2t minus 5? 2. You can't put in 5 because there's no more letter or variable. So the answer is 2 meters per second squared. Okay, this doesn't make sense to you right now, and it will once we get to chapter 5. Because in chapter 5, we really talk about when the particle changes direction. And all you have to remember this until you get into chapter 5. It changes direction when the derivative equals 0. That's when it's going to change direction. When the derivative equals 0. And it's going to ask you on the test, when does the particle change direction? You have to say in your mind, because we really don't talk about this until you see a picture of it. What's the derivative? 2t minus 5. You're going to set it equal to 0. You're going to add 5. You're going to divide by 2. At t equals 5 halves, 5 halves is the same thing as 2.5. At exactly 2.5 seconds is when the particle changes direction. It's basically when your derivative changes from positive to negative at exactly 0, if anybody cares. Okay, again, this will be on the test. It'll ask you to do the A. It'll ask you to do the B, the C, the D, the E. You have to know how to do all 5 parts. And it's a lot of points on the test, so make sure you understand. I'm just telling you what they did wrong on the test for years. Do you know what they did wrong on the test? This is in meters per second. The test is in feet per second or inches per second. And this is going to be on the review sheet to get you ready for the test, right? But they follow verbatim what's on the review sheet. And since the review sheet had meters per second, they labeled everything on their test meters per second, right? But it's going to change a little bit. You got to look at your units throughout the rest of the year. So really watch units for the rest of the year. Again, every year I'll write themselves a note and say, take one off because you're in the wrong units. So make sure you know your units. Okay, next part is another big part. It's a lot of parts. I think it's A, B, C, D again. Again, this is more physics, but again, it's all in words. You have a rock straight up in the air, launch a velocity of 160 feet per second squared. This is the initial position. This is the formula for the initial position. Again, you don't know this until we get into more class, but how high does the rock go? They want to know what's the maximum. Of course, it's going to look like this. Isn't that going to look like, well, it's probably here. You throw the rock up, it's going to hit a maximum somewhere, right? It hits a maximum when your horizontal line or your derivative is what? It's when your derivative equals 0. And I even left you a hint there, so you know that on the test. How high does a rock go? It's when you find your max, is when you set your derivative equal to 0. So the derivative should be easy. Just set that equal to 0. The derivative of 160t is 160. The derivative of a negative 16t squared is a negative 32t. Subtract 160, divide by negative 32. I'll just do it really quick. T equals 5 seconds. Is it seconds? Yes, I have to look at my units. At exactly 5 seconds is when that rock will hit its maximum. What is the velocity and speed of the rock when it's 256 feet high? What is the velocity and the speed of the rock when it's 256 feet? So you are going to set the original, did I spell it wrong? No, I spelled that wrong. I don't even know what I'm doing. Equal to 0. Whatever. What is the velocity and speed of the rock when it's 256 feet? So you're going to set the original equal to 0, which is negative 16t squared plus 160t equals 0. And you're just going to use algebra. They both have a 16t in common. Yeah, just take 16t out. Oops. I set it equal to 0. Sorry, you guys. Set it equal to 256. Doesn't want to know when it hits 0. It wants to hit when it hits 256. So now we have negative 16t squared plus 160t minus 256 equals 0. I don't like a negative 16. Well, I can take the negative 16 out. T squared minus 10t. 16 times 16, 256, I think, isn't it? Yeah. Yes, I can look like it. Yeah. Negative 16 I took out, so you're going to have a t squared minus 10t plus 16. You can't set negative 16 equal to 0. That doesn't even make sense, but you can factor this to t minus 8 and t minus 2, which gives me 2 times where the height of the rock will hit 256. It'll hit it at 2 and 8 seconds. And exactly 2 and 8 is when the height of the rock will be at 256. I need to go back to A one more time. I didn't find out how high the rock went. I found out how long it took to hit the maximum. So I need to finish that. I need to go back and put 5 back into the original problem to know how high that rock went. I got to finish it. 160 times 5 minus 16, and 5 squared is 25. So 160 times 5, I don't know what it is, minus 16 times 25, I did the math already. It's 400 feet. At 5 seconds, your rock will be 400 feet. So I'd like to just show you a picture. At exactly 5 seconds, your rock is 400 feet. That's how high your rock is. What is the velocity and speed of the rock when it's at 256 feet? Well, if it's at 400 feet, somewhere around here and here, it had to have hit 256 twice. Does that make sense that it would hit 256 twice? And where is it hitting it at? It's hitting it at 2 seconds, and it's hitting it at 8 seconds. Does that make sense? And then, what is acceleration? You just set the double derivative equal to 0. Here's the derivative. The 160 drops off. You get a negative 32 as your 32, what are we talking, feet per second squared? Negative 32 feet per second squared. And then they want to know when will it hit the ground again. Well, it starts off at 0, and without even doing any math, I think most of you know when it's going to hit the ground, right? Most of you, without even doing it. At 0, halfway there, it's 5, so obviously, how many seconds will it take to hit the ground? 10 seconds, without even doing any math. At 10 seconds. How do you get that? You can take the original problem, which is negative 16t squared plus 160t, set it equal to 0. I can take out a 16t, or maybe a negative 16t. T minus 10 equals 0. I set this equal to 0, I get 0. I set this equal to 0, I get 10. So these are the 2 spots when it will be on the ground at 0 and 10 seconds, which would make sense looking at the flight of the rock, parabolic. So again, you have to know what to do on a test if it says how high does the rock go. You need to think max or how low does the rock go. You need to think minimum or max, and you have to set the derivative equal to 0. What is the velocity and speed when it's at 256? You set the original equal to 256 and you do your factoring. Acceleration is easy, and when will it hit the ground again? You set your original equal to 0. You want to set your derivative equal to 0. Yep. Oh, yes. Let's go back. I'm missing a whole bunch of stuff. Yes. What is the velocity and speed of the rock when it's 256? We didn't actually found it. We just found the time again. I'm doing bad on this section. So you plug 2 back into the derivative, and you plug 8 back into the derivative, and I'm just going to give you, sorry, thank you, you're going to put 2 back in the derivative, and you're going to put 8 back in the derivative, and the derivative is it 160 minus 32t, and I'll just do the math. I already have it down here. I don't know why I missed it. This is 96, and this is a negative 96 feet per second. But if they're at, that's the velocity is 96 feet per second and a negative 96 feet per second. If it's going up, it's a positive 96 feet per second. If it's going down, I told you about the gravity of Earth, it would be a negative 96 feet per second. But they're asking you to find the velocity and the speed, and remember I talked to you about the speed as absolute value. So if they ask you for the velocity, it's both of these. If they ask you for the speed is just going to be a positive 96 feet per second. I forgot something in A, I forgot something in B. I'm losing it here, but we went back and figured it out. I have it in my notes, I just forgot. There's just so much to do on this problem. Okay, moving along. A chart. You'll have another try at this. We just had the quiz on this. You'll have another try at how to find the velocity using a chart instead of an equation. So here's what you should have done on your quiz last Friday. They want you to find the velocity at t equal 1, and they also want you to find the velocity at 2.5. On the quiz last Friday, you were finding the derivative. No, you were finding the slope, correct? It said to find the derivative at the midpoint, right? But now they have the word velocity. It's exactly the same concept. Here's one. You don't have to take the midpoint in this problem because they already have points for you, right? You can either do 0 to 2 because there's that one halfway between 0 and 2, right? Or you could do 1.5 to 0.5. It doesn't matter as long as 1 is between the two perfect points. And some of you did x over minus x over y minus I, but this one's always the x-axis, and this one's always the y-axis. So let's just quickly run through both of these. This was just on your quiz. You're supposed to make a chart. To find one, I'm going to do these two. I'm going to put the x's on the bottom, so 2 minus 0. And I'm going to put my y's on the top, which is a negative 8.5 minus 3.5. Which gives you negative 8.5 minus 3.5 is a negative 12. The negative 12 divided by 2 is a negative 6. Okay, on the test, if you just write negative 6, it's going to be marked wrong. Because they're going to try to catch you on the test with your units. You need to recognize that if they give you a chart, wait, maybe they didn't. They don't give it to you though. They just tell you seconds. They don't tell you meters or feet, do they? On the test, they'll tell you feet, seconds. I think this one, let's just do feet per second. Really watch out labeling your answers now. So, if they ask you to do 2.5 to find the velocity or the slope at 2.5, you only have one set of points to use. The x's go on the bottom, 3 take away 2. The y's go on the top, 3.5 take away negative 8.5, which ends up being a positive 12 feet per second. You will be guaranteed, you have to know how to do this for the AP test. You have to, and it's not even that hard. if you know how to find the velocity or the slope or the rate looking at a chart. It's not even that hard. If they don't give you points, you can do midpoints like we did on the quiz. So, any questions on part 4? We got a lot to do still. Even though it doesn't seem, there is, this takes a while. I think I'm done with all those notes. I think I'm already on this. Problem number 6, or problem number 9 in your book on page 136. Again, everything's important in AP. This is really important because you need to know how to read a derivative graph. So I already drew the picture on there. It's already on here, so I don't think you need to draw. But it says the velocity equals ft. The velocity equals ft. So that's not a position graph, that's a velocity graph. That is the derivative graph, right? This is a derivative graph. It says velocity equals ft, but it really means it's f prime of t. Everybody understand that? So, what is this saying? Look at A first. I don't even know what A says. A says, when is the particle's accelerator? No, forget it. I read it wrong. When does the particle move forward? When does it move backwards? When does it speed up? When does it slow down? So there's a lot of questions. Okay. When does it move forward? When does it move forward? It moves forward when your derivative is positive. It moves forward when your derivative is positive, right? Because derivative means velocity, right? So it moves forward from 0 to 1 because this is positive. So it moves forward from 0 to 1. It also moves forward from 5 to 7 because this part is positive. It's above the x-axis. So it moves forward from 0 to 1 and 5 to 7. It moves backwards when the velocity or the derivative is negative. Again, this is a derivative graph, so everything below the x-axis is when your slopes are negative. So it's going to move backwards from 1 to 5, and it's going to move, that's it. It's going to only move backwards from 1 to 5, isn't it? It's the only part that's negative on that graph. It changes direction. It's moving forward and moving backwards. It's got to change direction if you're moving forward and backwards, right? It's going to change direction. Write this down. I know it's not on here, but it's going to change direction at 1, at 5, and I guess 7 it would kind of, 1, 5, and 7. When it goes from positive, it's going from a positive slope to a negative slope. And you guys are like, no, that isn't. This is all negative slopes, but it isn't. This is the slope. This isn't the original graph. You guys understand that? This is not the original graph. These are all positive slopes. These are all negative slopes. These are all positive slopes. And this is a slope of 0, right? That one has a slope of 0. When does it, what's the next question? When does it speed up? When does it slow down? So, you have to think of velocity. Are you guys thinking physics here? Velocity. It's going to speed up. It's going to speed up when your slope is positive and it's increasing. You know what I'm talking about? It's when it's going to speed up when your slope is positive and your graph is increasing. Or it's going to speed up if your slope is negative. Where's your slope negative? Right here. Isn't your slope negative? But What does it have to do if it's going to speed up? Your slope needs to be negative and you need to be doing what? Decreasing, right? Your slope needs to be negative and you need to be decreasing. I guess I should say it really. When does the slope positive and increasing? Well, this is a positive slope, but which way is it going? Decreasing, so it's not happening there. Right here, your slope is positive and it's increasing, so from 5 to 6. Here, your slope is negative and decreasing. I think there's only one spot where your slope is negative and decreasing, from 1 to 2. When does it slow down? It slows down if your slope is positive. Your slope is positive, but decreasing, and it's also going to slow down if your slope is negative and increasing, right? They're pulling away from each other. Does that make sense, you guys? So where is it where your slope is positive, but part of it's decreasing? Slope is positive from 0 to 1 and it's decreasing. And, I don't even know, 6 to 7 is it about? Or slope is negative and increasing is 3 to 5. On the AP test, they're going to ask you questions like this. And you need to know how to read a derivative graph. You guys made a derivative graph, but you need to know how to read a derivative graph. Again, this stands for the positive slope. It doesn't stand, you're not really looking at this whole line. You're looking at when it crosses it, positive and negative. This is a positive slope. This is positive. This is positive. This is negative. This is negative. This is negative. This right here has a slope of 0. It's not positive or negative. So, okay, next problem here. Guarantee you, you're going to see one of these. This will be a multiple choice question on the AP test. They're going to give you the position, they're going to give you the velocity, and they're going to give you the acceleration, all on the same graph. Remember how you made your booklet and you made the position and underneath was the derivative? Now we need to find which one is which. So, what you need to do is the key point is when your slope is 0, correct? So, this one right here is when your slope is 0. Doesn't this one have a slope of 0? Right there at that spot, okay? This part has positive slopes, so are these all positive? Are these all positive in this direction? Are these all negative in that direction? So is the red line the derivative of the parabola? Do we understand that? But now what does the green line go in? The green line, do you notice important things about the green line? You always have to look at the green line and decide. You need to have a 0 on the derivative graph, right? And you need to have 0 on the derivative graph. So do you notice that this one needs a 0 on the derivative graph and this one needs a 0 at the derivative graph? Everybody see that? So which one is the position graph? Isn't it the green one? This is the position graph. Because this one is this one, and then the parabola, which is right here, is the velocity graph. And then the little red line is the acceleration. And you need to do this without trying to think of the functions, but a lot of you know that this kind of makes an x squared graph, correct? And every x squared's derivative is 2x, which would look like a line, but you can't think like that every time because the shapes are going to be so weird. You should be able to tell by looking at it. What you need to do, though, is you really need to look at where your horizontal tangents are. That's going to help you decide if it's position, velocity, acceleration. You're only going to have one of these on the AP test, and it'll be in the multiple choice. Non-calculator. Do you need a calculator to do this problem? You don't need a calculator. So this is a non-calculator one on the test. Okay, last part, part 8. It's called Handout on Marginal Cost. We have 10 minutes. The people that are gone will have to get the handout on marginal cost. Tons of homework, always, but I made a hole punch in there so you can put it in here. Students that are gone, come and pick up one of these maybe at the end of the day. They probably won't even listen to this till tonight, right? So they won't pick it up. Yes. Anybody else want to give to their friends? Anybody want to give some here? Here's the cat. Yeah. Okay. So marginal cost and marginal revenue is outside of my box. I teach calculus, and this is where you would find this. Marginal cost. If you're not going to be an engineer, you still have to take calculus if you're going to be a business major, you guys. If you don't know that, if you're going to be a business major, you still have to take a form of calculus. All of these occupations deal with rates of change, and I wrote all this down, but geologists, if you're going to be a geologist someday, you need to take calculus because calculus deals with rates of change or derivatives, right? Geologists deal with the rate of molten rock flows. Engineers deal with rate of water flows into a cylinder. Urban geographers, rate of change of the population. And meteorologists, the rate of change of an atmospheric pressure. I think Jay Cartzel wants to be a meteorologist or go into that field. You'll have to take it because you have to figure out the rate of change of a lot of things. So, okay, down below I bolded it. Business majors in college need to work with marginal cost and marginal revenue, which is the rate of change of business majors. For some reason, I think this is on the AP test, which deals with marginal cost, which is outside of my box because I'm teaching more towards an engineer major and not a business major. So, how do you deal with marginal cost and marginal revenue? So, here's an example of a problem that a business major would do, and this equation is the cost to produce the X amount of radiators in a shop. So there's the formula to produce X amount of radiators in a shop. CX equals X cubed minus 6X squared plus 15X. The second equation deals with, gives the dollars of revenue for selling the radiator. You're hoping you're selling it more than what you made it for, we hope. Right? Else you would might as well bankrupt. So anyway, Rx equals X cubed minus 3X squared plus 12X. So far, so good. They're going to ask you a question on the next test about marginal cost and marginal revenue. So here is the problem. The company is currently producing 10 radiators. How much will it cost to produce one more radiator in the shop? Again, isn't it changing? Isn't it the rate of change? It went from 10 radiators to just one more radiator. You guys got that? So if you turn your paper over, all you're going to do is find the marginal cost and the marginal revenue. And marginal cost is the derivative of cost, and marginal revenue is the derivative of revenue. You guys got that? So the front side are the two equations for the cost and the revenue, correct? The key word is marginal. When you see the word marginal, it means what? Derivative. So when you see the word marginal on the AP test, if you see the word marginal, all you have to do is take the derivative. This is more of a business name. I mean, I'm going to see the word speed. I'm going to see the word velocity. I'm going to know right away that's derivative. But now if we're talking business names, if you see the word marginal, it's derivative. So all they did on the back side, I'm just going to do this for you. You can follow along. On the front page, I gave you the two formulas. X cubed minus 6X squared plus 15X. And Rx equals X cubed minus 3X squared plus 12X. Correct? That was on the front side. If they want you to find the marginal cost and marginal revenue, I didn't finish this, marginal revenue, all you're going to do is find C prime of X and R prime of X, which is 3X squared minus 12X plus 15. And our prime of x is 3x squared minus 6x plus 12. Just take the derivative of those two. Then what you do is you plug the number 10 in there. You don't plug in 1, you don't plug 11 in. You want to know, because it's already changing on you. This is the formula of how it's changing on you. All you're going to do is you're going to put the number 10 in this one and 10 in this one. And when you put 10 in the first one, it makes $195. When you put 10 in this one, it makes $252. So it's going to cost $57 more to produce one more radiator in this shop, because all you do is you subtract these two. And you're hoping, like I said, you're hoping you're making it and selling it for a higher price. We hope so. But it's going to cost you $57 more to just make one more radiator. That's how much the rate of change is, to make one more radiator. So when you hear the word marginal on the AP test, you'll say, well, that's just another name for derivative in the business aspect. We never talk about business ever again in the rest of this book, so I don't even know why they're showing you this in this section. I mean, they could have showed you a problem on a geologist or an urban geographer or a meteorologist, but they're not. They're showing you a problem about a business major who has to deal with cost and revenue of producing a radiator. Some kids put the 1 in there because that's one more. You have to put the number 10 in there because this is the derivative of the rate of change. You don't just put 1 in there, you actually put 10 in there. So you're going to have a question like this, so make sure you know how to do it. And I'm hoping that this number is smaller than this number when you're doing it, or else it doesn't make any sense. We're all done with notes. That's it. There's no more notes. You still got 5 minutes to go.